Hey guys, today what we're talking about is computer integrated manufacturing. Okay, so this is often, I think, we might call this automation. Okay, so basically, this is the definition from the glossary of terms. It is a system of manufacturing that uses computers to integrate the process of production, business, manufacturing in order to create efficient product lines. Right, so you definitely need to know that. Um, but in a big scheme of things, what it is it's essentially trying to integrate computers into the entire manufacturing process. So this is from design through procurement of raw materials into the manufacture of a product and finally into distribution of it. So all the way through the entire product production line. Okay, so watch this video. It's pretty interesting. It's it's about a minute long, and it kind of just gives you a decent idea of what's going on. This is a bit of an older video, and I'm sorry about that, but it's an Apple computer manufacturing plant in the U.S. And one of the things that I want you to pay attention to as you're watching these two videos has to do with what people are doing on the production line floor. So in the old days, and this is something that you have to try to imagine, in the old days, what you would see people doing is you would see human beings standing at machines and they would be doing the machining of the different components that would go into a product. What you don't see in these two videos is people standing in front of machines and actually doing the machining. I mean, like actually using the machining equipment and doing it by them, by themselves, right? What you do see is people standing in front of machines working on computers. So they're monitoring the computers, they're programming them, they're essentially working in that capacity. Now, this is what is causing a lot of loss in manufacturing jobs around the world. It's pretty interesting. So, when you hear people talk about the fact that manufacturing jobs are being lost to being shipped overseas, that's actually not true. I mean, some of that's happening, but more and more, what's happening is that people are losing their jobs to robots. So essentially, this is what's taking people's jobs right here. This yellow robot. They're taking people's jobs because they can do it better. They're cheaper. I mean, there's a big outlay of capital to acquire them. But once you've got the robots, they're better at producing things. They don't take breaks. They can work 24 hours a day. They don't take sick leave. They don't get COVID. So this is what's actually taking people's jobs, not being shipped overseas. I'm constantly saying that it's better to be someone who produces the robots than to be somebody who got their job taken by a robot. So just consider that as you're moving forward in your careers, that you don't want to be involved with something that is easily automated. Okay, so that's an important consideration for you guys' future. So just watch these two videos. Like I said, they're pretty short. This one's a bit old, and I apologize for that, but it gives you a good sense of what's going on the actual production line floors. The other thing I would say is that the people who now work on these production line floors, and I'm going to go back in time. In the old days, they were relatively unskilled, and you could sort of get by with a high school education and work on a production line floor. Nowadays, you need a university degree because you need to understand the math, the science, the computer science, the logic that's involved. And you need to be able to speak intelligently with engineers and designers about production. So it's actually becoming, the people on the production line floors are becoming more and more educated and need to be more and more educated just to understand what's going on. Okay, so let's move on. Here's some elements of computer integrated manufacturing or SIM. So here we go. We've got CAD, of course, right? And this is, it's super important that you understand how to use CAD software because this is how people design nowadays. Okay, so not only are they designing, but they're also testing in CAD software. They're creating materials. They're not creating materials, but they're creating their products out of sort of virtual materials and testing them, right, to generate data. They're planning, so they're planning how the production system is going to be, and that's based. The computers are using the database that in the design process was tested, right? So they're using the data that you generated in the tests in the design to help them understand how they can actually efficiently produce something. Purchasing. So computers are more and more involved with the buying materials and purchasing materials. This is something that basically what they'll do is a computer will know when a certain raw material or component is low, and then we'll be able to order it just in time. So it's basically employing that just in time mentality. But the computer is in charge of this. They're even talking about this with your refrigerator. That they've talked about smart refrigerators for a few years, where you would basically your computer or your refrigerator would scan the inside of your inside and know when you're, say, low on milk. So rather than you noticing that you're low on milk, your refrigerator would notice that you're low on milk, and then it would then order the necessary things that you normally keep in your refrigerator and have them delivered to your house. So this is kind of that same idea, where in manufacturing, if you're running low on a particular component or raw material, computers will actually be in charge of purchasing those materials, and that's a loss of a job right there, because that used to be somebody's job, would be procurement. Cost accounting, so they're going to do things like budgeting. Computers, again, this is all about computers, right? So computers are going to be doing the budgeting of the production process, the receipts, etc. Basically deciding prices and things like that. Inventory control is tracking materials, products, and is, again, getting back to that just-in-time methodology. And distribution, so it's going to also be in charge of contacting things like vendors and warehouses where products are stored, and saying, hey, we've got, here's these are the materials they're going to get to you at XYZ time frame. It's interesting. So this is all about automation, and essentially along most of these pathways, you're losing people's jobs that used to be relatively well-paying jobs. So it's something to consider as an advantage and disadvantages of this system. It can be cost-effective, but you also are creating you're basically designing out jobs. You're automating jobs out of existence. Okay, so how does this relate to scales of production? So this is something the IB wants you to know. It wants you to think about how computer integrated manufacturing would relate to certain scales of production. So if we're talking about one-off production, there's really very little advantage to using this, because it's just the costs are too high, right? If you're producing very small numbers of custom-made things, it's too the cost is just too high to get all of these machines and things like that. So you're not gonna do it, right? And it's also not very well suited for non-complex products. If you have something that's fairly simple, it's not well suited for that. So there's really no advantage to using computer integrated manufacturing currently for one-off productions. Now, batch productions, there's a ton of advantages, right? It's really well suited for this, because it's highly flexible, and there's a lot of flexibility in the automated systems. It's suited for volume and mass due to the full automated nature, right? So you can produce, remember, batches don't necessarily have to be just 20. It can be millions of things, right? But the idea with a batch is that you're producing a batch, and then you are then going back and modifying it in some way, and that's something that's this production system is well suited for. Monitoring the systems at all times, so computers are always checking the system. It's not humans, that are doing this. It's computers, and computers can sense things that we can't. It's really great. It basically is going to be the most efficient for using the machines that are available. In other words, there's not going to be any idle machines while things are happening. The computer's going to utilize them in the most efficient manner. There'll be fewer errors and waste, because computers are just better at doing certain routine tasks than we are. There's improvements in productivity and quality control. There's greater consistency. Then that means all of these things mean that there's cheaper products. Parts are easier to be manufactured and changed. They can do random introductions of parts, so randomly they can introduce new parts. There's less lead time, so it doesn't take as long to make something. There's less labor, so that's a cost-saving thing. But again, it goes back to this idea of it's a disadvantage of job loss, and you get a higher quality product. Now, some disadvantages is, man, it's expensive, right? Like those robots and things like that are, they cost, I would say $500,000 to, I don't know how much they cost. They're expensive, you know, so that's something that's going to be very expensive. The people who you do have working, if you're planning to keep them, then you're going to need to educate them, and they need to do a lot of training, and so training costs money. Um, yep, automation is going to cause people to lose jobs, right? So this is a huge problem with it, and also there's a lack of individuality, right? You're not really an individual anymore. You're kind of helping the computer along. So I don't know. That can be a sense of people losing their individuality to the system. Okay, mass production. So with mass production, you're going to end up with more choice, right? Because the computer, you can program it to give you some variation within products, which is one of the big disadvantages of mass production, if you remember, that there really wasn't a lot of customization. But with computers controlling it, you can add more choice to that. You can design its own requirements, cheaper products again. So things are cheaper, parts are easy manufactured and change, random introduction of parts, less lead time, higher quality. So those are similar to the batch production. And again, these are very similar to the batch production again. So there's a high initial investment, training costs, and job loss. Okay, so what are some advantages and disadvantages as far as investment and maintenance? So some advantages is the system is constantly monitoring, right? It's a computer, so it's constantly, checking on things. It can find the location of breakdowns and identify them to make maintenance easier, right? This is a problem in unautomated. So when you don't have a computer-controlled manufacturing, you may not know that there's an issue until too late. So that can reduce the cost of maintenance because you're catching small things before they become big things. And then after you've invested in these really expensive machines, you can have greater profits, right? Because then you've reduced your labor cost, you're making higher quality products, it's cheaper to produce them. So, after the high initial capital investment, you can actually make more money. A disadvantage again, very expensive, right? So that's computers, robots, and training of people. And then maintenance can be, you need highly skilled employees to do maintenance, right? This is not, it's interesting. It's similar to the way cars used to be and the way cars are today. So, cars are essentially so computerized today that you need more or less a computer technician to tell what's wrong with a car. You can't just simply have, somebody who can take the car apart and figure out what's wrong, and so it's the maintenance is much more complex. So those are the main advantages and disadvantages of the investment in maintenance, and this is something that the IB also wants you to know. All right, thanks for watching.